Namaste to all my dear students. How are you? Again, I am giving you very interesting lecture about the lab preparation and properties of phosphine gas, and generally asked in examination, and that is also very useful for knowledge. So lab preparation properties of phosphine gas. That is very important. Just at first, lab preparation of phosphine gas. So its molecular formula is MF is PS3. Molecular weight is 31 plus 3, how much? 34. Its vapor density is how much? 34 by 2. So molecular weight by 2, 17. So its principle is like this. So when white phosphorus is heated with caustic soda, we get mixture of phosphine gas, diphosphine gas. Its formula is P2S4, which is passed into U-shaped tube, you can say U-tube containing freezing mixture where diphosphine gas is condensed into liquid and uncondensed phosphine gas is collected in gas jar by downward displacement of water, because it is slightly soluble in water. Yes. So that is about the principle. Now reaction involved over here. reaction involved. So, what you see, white phosphorus, that is the white phosphorus plus sodium hydroxide plus what you see, H2, that is heated inert atmosphere. Yes, what we have, NaH2PO2 plus phosphine gas, that is sodium hypophosphate, that is phosphine gas. Yes. So, after balancing, what we have, 3 NaOH, 3 H2O, 3 NaH2PO2. Yes, that is the balanced chemical equation. Yes, sometimes so what we say, note, if round bottom flask contains air, phosphine gas reacts with air in presence of diphosphine. Formula is P2S4. Of diphosphine gas, we get vortex ring of phosphorus pentaoxide, which is very toxic and highly inflammable. So, we have to remove air as well as diphosphine gas. Yes, what we have? So, that phosphine gas react with air in presence of diphosphine gas. So, what we have? Phosphorus pentaoxide plus water. So, what you see after balancing? After balancing, what you see? After balancing, we get 2PS3 phosphine gas, 4O2, P2O5, 3H2, that is phosphorus pentaoxide. Vortex ring is like this. That is the vortex ring, which is very, very poisonous as well as inflammable in nature. Yes. So, never air and what is it, diphosphine gas present inside the round bottom flask. Yes, that is about how phosphine gas is prepared in the lab. Next one is the lab preparation. Next important properties of phosphine gas. First one is as basic. So what you see, pH 3 reacted water, and what you get, that is phosphonium hydroxide. Now this phosphonium hydroxide, after ionization, what you get, pH 4 plus. So it is very weak base, very weak base. Yes. So if this very weak, so according what you see, similar to ammonia, react with what you see, pH 3 HCl. So what you get, phosphonium chloride, white fumes. Next one is pH 3 HBr. So what you get, what you see, liquid below 30 degrees centigrade, that is phosphonium chloride. Likewise, react with hydrogen iodide, that is base, weak base, that is the acid. So what we have, phosphonium iodide. That is what we see, transparent crystal. Yes. So what you see, phosphonium is what you see, white fumes. Phosphonium bromide is what you see, liquid below 30 degrees centigrade, and phosphonium iodide is what you see, transparent crystal. Yes. So which has very weak base. Next important properties is, second one is reducing properties. Reducing properties of phosphine gas. So when phosphine gas is passed through copper, gold, silver, salt solution, separately, we get phosphide of respective metals which on standing or boiling converts or better to say reduces to metal. Like, so when suppose copper sulfate solution when treated with pH3, so what we get? Cupric phosphite. So what type of PPT over here? Black PPT. Plus side product is what you see? Sulfuric acid. Yes. So now this cupric phosphide on boiling, or we can say standing or boiling, what to get? Copper plus phosphorus. So what we see? P4 means we have to multiply by P. So what you see? So what is it? Metallic copper over here. What to get? Metallic copper by reduction process. Yes, so after balancing what we have, so what we see? 3 copper sulfate, 2 PS3, 3 H2SO4. Yes, and that one that already balanced over there. Next one is reaction with gold, that is auric phosphine gas plus H2O. What will auric gold plus, that is phosphorus, what you see? Acid plus 6, balancing what we have? 2 AU, PS3, 3 H2O, 2 gold. Yes, arrow indicating downward, that is arrow indicating downward. Yes, so what do you get? Metal, copper versus gold. Likewise, Ag plus phosphine gas plus water. What you get? Ag plus phosphorus acid plus 6S plus. So after balancing what we have? 6 Ag, what is PS3, 3H2O. What you get? 3 Ag, silver metal, that is phosphorus acid, I have already told you, that is phosphorus acid. Yes. So generally that reaction is very important. So this reaction is used as test for phosphine gas, because at first what we get? Black PPT and where cupric phosphide, that is compound is cupric phosphide. Yes, when that is standing or boiling, what you get? Copper. That is what you see we can use as a test for phosphine gas. Yes. To reaction generally asked, and that is important for examination. View of point. Next one is differences. Differences in between phosphine and ammonia. Yes, so that is phosphine. Formula is pH3. That is ammonia. Yes. So at first to talk about the smell. Similar to fish. Yes, it has pungent smell. We can say irritating smell. Irritating, similar to general toilet. General toilet. Yes. Second one is, it is highly poisonous in nature. It is non-poisonous in nature. Third one, it is slightly soluble in water because it does not form hydrogen bond with water. That is, it is highly soluble in because it forms hydrogen bond water like what you see. Suppose H, that is ammonia. So what's oxygen? Electronegative value of oxygen is 3.5. Hydrogen is 2.1. So it has slightly negative, it has slightly positive, and that is weak hydrogen bond in between water as well as ammonia. That is water. That is ammonia. Yes. Fourth, it is slightly basic in nature because it does not turn what you see red to blue moist, better to say moist, red to blue litmus paper. It is strong, basic in nature because it turns what to say red to blue litmus paper. Reaction is like this: NH3 and waters. What we have? Ammonium hydroxide. Now this ammonium hydroxide, after ionization, what we have? Ammonium plus hydroxide. Yes. Fourth, fifth, it is heavier than air because its vapor density is 70. It is lighter than air. Its vapor density is 8.5. To get 8.5. Yes. Next one is reaction with copper sulfate solution, that is the test. So what we see over here? Copper sulfate plus PS3. So at first what we get? Cupric, black PPT, cupric phosphide plus what you see? Sulfuric acid. Yes, after balancing what we have? 3 copper sulfate, 2 PS3. What you get? 2 PS3, copper phosphide, 3 H2SO4. Yes. So we have already studied in ammonia chapter. So what you see? Copper sulfate plus ammonium hydroxide, low, less you can say. So what to get? Copper hydroxide plus, so what type of PPT? Bluish white PPT plus side product is ammonium sulfate. Yes, in this case when we use what is the ammonium hydroxide excess, so what we have? We get tetra plus what? What is it? Tetra. How many? Tetra amine copper, second oxidation number is 2, 2 sulfate. Its color is deep blue, or we can say indigo color. Yes. So that is the what's the main difference in between the ammonia and phosphine. So in this case, sometimes ask you how can prepare what is the phosphine gas in the lab, what are its main chemical properties. We have already seen basic and as well as reducing properties. Next, what are the differences between the what is the phosphine gas and ammonia. So I think you have clear. These are things we have to remember in mind. Always we have to practice. So perfect. Practice makes a man perfect. If you do practice, we have never problem. Yes. So thank you very watching. Thank you very much for watching this interesting video, and I think you have subscribed it. Also convey channel to your friends for learning. So have a nice day. What to say? Be bona fide in chemistry like Sheila Kansar. Thank you.